Hey guys, good afternoon, good morning, good evening, whatever your local time zones are. Thank you so much for joining. Today we have Rafael speaking on generative AI, semantic search, and RAG pattern. Welcome, Rafael, and thank you so much for allocating some time to speak from our meetup group and on a wonderful topic. Back to you. Would you like to introduce yourself?
Hi, everybody. Thank you, Swami, for introducing me, and thank you all for having me in this user group. I do care about user groups. I am also a maintainer of the local user group, so I know very much how difficult it is going on with all this stuff. So I am an electronic engineer, and I work with software since DOS 1. So it's a very, very long time that I spend all my career on software and then developing software stuff. So I have seen all the things about DOS, Windows, Linux as well. And I spent a lot of time since the very beta on the very first beta with .NET, and I am a 21 years old MVP. So it's a huge amount of time. That's a wonderful time that we are living. We are in a new era, the era of the AI. It's nothing new from the mathematical perspective, but it's something that is growing very fast because of the new, section of the generative AI, which is so special because it gives us the possibility to talk with machines in a certain way, and we will want to understand better what is happening in this field and why this is so special and what's the difference with the old models. So, Swami, do you want to tell anything else, or should I start?
Oh, Rafael, it's all yours. I'll be on the backstage.
Okay. Sorry?
Oh, it is all you. I'll be on the backstage. You can
Okay.
continue.
I can go. So if you have questions, feel free to write in the chat. There is Swami that will take the questions, and if there is something interesting, he can interrupt me, of course. Otherwise, we will have a nice Q&A at the end of the session. So I will wanted to focus specifically on the things that are let you understand exactly what is happening in this field and how can you take out of the best of it. So behind that, I want to stress you. If you search me on at Raffaele, you can find me on Twitter and so on, also on LinkedIn. I am an engineer. I'm very deeply involved in the local engineering community. I am also from time to time a teacher in the university. I also have as a member in the ICT Commission of the Association of Engineers. And I used to work with many industries. So I am a consultant. So I work with manufacturing in F1 racing. And you can guess, since I live in Italy, which one. And also the healthcare industry, which is extremely interesting from very different perspective, and financial. So all these different experiences gave me the possibility to understand problems from very different perspectives. So the way you solve something, exactly the same problem is solved differently depending on the industry you are working with. And this is was a huge opportunity for me to, think differently, let's say, And so I started talking in 2002, 2003, when I was giving training and training courses also in Switzerland. And I then traveled all around the world. I went to, Russia before the war, and the USA, Eastern Europe. I was in Slovenia a few months ago, and I will be again in September, in Romania and Bulgaria, and in Germany a few weeks ago, and so on. So for this reason, since I live and breathe the community, I am a proud member of the Microsoft MVP community. And by the way, I wrote a couple of books. This is very old, I mean, from the time of the university, about electronics and physics electronics. And this is more recent, the C# programming that you can see in over my shoulder. And then this was co-authored with Marius Bansila from Romania and Ankit Sharma from India. So we are the three authors of this nice book, and which is also still very, I mean, relevant, even if it covers C#8, because you know, you have new features, but the old one doesn't go away, and so there are all the stuff about synchronous and so on that still stay there. Anyway, let's go to the topic. One thing that I see, the very first mistake I see from, I mean, the common street people that I talk with, is that they try to use ChatGPT as a search engine. Please don't do that. I mean, ChatGPT is not a search engine. You can find a lot of things about a lot of information with ChatGPT. You can ask things and it answers back. You get and say, "Oh my God, that's astonishing, that's wonderful." But searching is something that can give you good result, but also very bad result. Let's be very, very clear. Also, with Google, you can get bad results, right? You get a lot of bad results in many cases. But it's, I mean, more dangerous with ChatGPT because it's, I mean, nicely crafted answer where you read that and you say, "Oh my God, that's it," and you take as the truth. And so, how can you trust this information that comes out from this model? And you have to understand exactly how this thing work before knowing if it's cheating or not, and we will see that. So there are pros, of course. No, there are the ChatGPT and the GPT models in general retrieves content that are related to the question, even if you don't have a matching keyword, which is a good enhancement from the old version of Google search. Nowadays, Google search makes a kind of mixed hybrid search using both AI and keywords. But if you remember back in the days when the keyword did matter, and you know that, I mean, I missed that keyword, that's why I didn't find that article, and so on. So this is a good way, because you have a lot of synonym that you don't know exactly which one is better in order to find the information you're looking for. Then answer focuses on the, I mean, on the context of the question, and then you don't need to read tons of the content of the articles that the information came from. And this is another advantage. So you have a short answer that is exactly match what you asked for, and you don't have to care too much about what's that. I have to read like 10 pages of an article, and then in the end, in a couple of lines, you find the sentence that say, "Oh, this is what I was looking for." And also, it is able to build content from something that doesn't exist. But that is true. I mean, it's the true is maybe a summary of a huge amount of information, and ChatGPT is able to give that. And this is the pros and the reason why a lot of people is so enthusiastic about ChatGPT. But there are also cons, of course, and these cons are very important, and you have to carefully evaluate when you use it. So your answer, the prompt, must be very specific and well structured. You may have noticed that depending on how and what you write, you obtain very different results. And the difference is wider than Google search. So every little attribute and word that you put in your question can literally trigger a totally different answer. This is very, very delicate. You have to evaluate that. And also the model knowledge is updated less frequently than Google search. You can go to the Bing search, for example, which is powered by GPT, but it does something else that we will see later on. And but it's very different. I mean, if you want to rely just on the model and on the knowledge of the model, that's totally different. And the reason for this update frequency is the cost, of course. And we know that nowadays training a GPT model is very expensive. Also, the responses can contain very unrelated content. So the problem of the hallucination, and the hallucination is something that you have to fear, because if you rely on that, you get it wrong completely, and that's very important. In general, you have to understand that when you use a GPT model or a generative AI model in general, you are just asking for a completion of user sentences. So it's a kind of a probabilistic response in which you say, okay, if I ask this, the most probable answer is this one. This is the mindset that you have to focus on when you make a question to a generative AI model. And we will see exactly what I mean on that. So, I don't want to explain everything now, but you will understand in a minute. And today's goal is kind of understanding how can we, rely on the information that comes from ChatGPT for other purposes, just like out of the completion stuff that is very good at. So let's make a small step back on how an LLMs and large language model work. So these models are neural network, and they basically are structured with several layers, and all of these layers, there are basically sums and multiplications, nothing, fancy. And given that they have these small numbers called as bias and a few parameters, they adjust how the information is processed, trying to mimic what happens inside our brain. And that's it. And there is nothing specific. So the problem is that how can we translate a question into numbers, because a neural network can only process numbers. And the answer is that they transform this prompt, these words, into tokens that are specifically pieces of the word or entire words. So just few characters or entire words, depending on a table that was decided by OpenAI, and there are different also. So explain quantum computer is just 3 tokens, and you can see the matching numbers. You can find it on OpenAI specification. It's a freely available info. Or indivisible, and you see that the ind is shared also with the inducted, and it's translated in 3 tokens, just 1 word, or 3 tokens for this other word. And you can see 485 is ind, and so that's it. You don't have to care too much about that when you write a prompt, of course, right? But that's important to understand how it works. And so these tokens define the starting point for the text being generated. What does it mean? So basically it means that when you input these numbers into the neural network, you basically initialize the parameters of all the layers with thanks to these numbers. So you start processing that, and at the very end, inside this huge neural network, this multiplication and sums and so on initialize the network in a certain way. And those numbers are fundamental to understand what comes next. And what comes next is basically the result of the most probable token that would follow. That is the reason why we are talking about a completion. So it's a what's the next probable token of explain. It may be quantum, it can be any other word, but we have billions of parameters, and so this following token is something that depends on the training, of course, and on the initialization. So the prediction of the next probable token is the main job of this model. And you cannot expect more from these networks. I mean, that's it. That's the way it works. So if you take a nice example and when you say, let's try to check the ability to complete some text. And it's a long way to the top if, and what's, I mean, if you read this and you're, different cultures, different songs, but if you are, I mean, a big fan of AC/DC like I am, I mean, you cannot miss that. And if you ask this to any of the modern LLMs, you will get "You Wanna Rock and Roll" because you don't find many other words, many other sentences that starts with "It's a long way to the top if," and the most popular completion is "You Wanna Rock and Roll," and that's it. Okay, so it's pretty obvious that if you start that and you ask the GPT model to complete that, you get "You Wanna Rock and Roll." And so we can also repeat online that. And so if I go to my demos and have the completion, it's a long way to the top. I start with these parameters. This is just an my own experiments. If you want to rock and roll, you see, I just repeated it live, and you can ask 1,000 times. You will always get that. I mean, that's it. But what happens if I prompt the completion of "We are the"? So there is a problem here, right? Because if I ask you this one, and I have to spoil that I am a huge fan of Queen, and I was at the concert in '84 with Freddie Mercury, so huge fan there. For me, it's obviously "We Are the Champions," right? And and you may have guessed why you may have guessed, because this is not so obvious that the completion of "We Are the" can go to champions rather than many other possible sentences, right? And the reason why you may have guessed is that because you have a context of the previous completion. So we just talked a few seconds ago about the music, right? And so if your brain was initialized, your neural network was initialized with the completion of you, it's a long way to the top if you want to rock and roll. And so it's quite obvious that most of you may have think to "We Are the Champions" just because we were talking about music. So the issue here is that when you just type this sentence to the model doesn't know what you are living, what you are ordering, what you are listening, what you thought 2 minutes ago. And that's the difficulty of prompting, because when you prompt, you have to explain the context. And if you explain the context that we were talking about AC/DC, give me a completion of "We Are the," and they probably can guess that there is champions right after that, okay? And this is the reason why prompts determine the persona with the system prompt, and we will see in a second, and the context of the expected completion. So you expect this complete with the champions, but it can complete to anything else. And this anything else depends on the context, which is something that initialize our neural network to the numbers that will provide the expected completion. So the system prompt, for example, could be: "You are an expert in Queen's band song. You only complete the titles provided by the user, and you don't repeat the entire title. And this will complete with just champions. There will be no other word. Okay. Well, you have to go to a very sophisticated LLM to do that. If you try to make these completions with a Phi3, for example, which is an offline model made by Microsoft recently, which is very, very good, and you can run on your laptop maybe, or maybe if you have a desktop with a good GPU is better, and you have to have a large amount of RAM, but you can do that. And you will see that these models behave like a quite different way, because it depends from the amount of information they retained inside the model, not to make them too large. And so you always have to carefully evaluate your completion depending on the model that you are using. This is very important. You cannot rely and say, oh, I trained this on GPT-4 and I go to GPT-4o and I will have the same behavior. Oh, no, no. You have to retest that. Okay. And that's the reason why you have to restrict the context very, very carefully in order to make the probability go in exactly the direction that you want to be. And you don't have to leave some open doors that maybe a different version of the same model can answer differently. Okay, that's super important. This is the reason why we call this prompting stuff, we call it prompt engineering. Okay, because it's becoming a discipline that is very, very strict and rule-based, like the engineering world usually is. So what are these prompts? A system prompt is used to constrain the user prompt, and this is mostly due to avoid security issues, but also to define the persona. So what is the role of the assistant that is you are talking with, okay, that is talking to me, and the general context. So which area are we talking about? You are an expert on Queen's song. You are a virtual waiter of a restaurant taking order given this menu, for example. Okay, this is important. You have to provide an explanation on which area of the human world you are covering in this moment. If you want to use it in a generic way, like the Google search, you will discover that the ChatGPT is going very badly. And the first thing to avoid this genericity is to provide a system prompt. So the system prompt is vital if you want to use the GPT models inside your application, right? Okay. And so user prompt is the question from the user. This is the simple one. So mention which songs are about cars, for example, okay? And then model are stateless. This is something that not many understand, but if you think about the neural network, is something that you provide an input and provides you an output. So what does it mean? It basically means that once it is initialized, you answer everything that pops out from the model is basically something that depends on that initialization. So you have to provide the context in order to extract what you expect. And they cannot freeze this model for you, waiting that you maybe go for a coffee and comes back and say, I want to continue the conversation before, now I type something else, and so on. So basically, every time you get an answer, the model is flushed, so is cleaned completely. And of course, you cannot even just make your last question continuing a conversation, because if you don't provide the previous question and also the answers, you basically are not telling the whole story to the model. So the model has no memory. It totally forgets everything. So you have to send every time the whole conversation, all the previous questions, and also the answers from the assistant. Okay, I said that, you responded this, and then I asked back this other thing, then you responded this, and so on. And even if the conversation is very long, you have to send everything. And this is something that explain why the prompts are that are limited in length can be difficult to manage. Okay, so you have to count also the token that you are using, because if you use too many tokens, you will also incur in an expensive conversation. So you may want to keep the conversation smaller, okay, and well focused on a given arguments. Otherwise, you will need prompts that are way too large. A typical token, prompt length is very large, is 32K. But if you think about a whole conversation going on and on, 32K is not that much, okay? And the maximum and lower token of the model, of course, which includes everything, depends on the system, on the model that you are using. You may have, good models that are very short prompts, and others that can allow longer prompts. I will give you an example of hallucination. So when does the GPT-4 behaves badly? And we have a question that came from my daughter, and she said, I asked a GPT to provide a summary of the Pirandello story, The Wheelbarrow. You probably don't know that. Doesn't care. And the answer that pops up, it looks credible. The Wheelbarrow is a short story, blah, 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 and let's don't care about that. And I then made an explicit question. Is there a dog in the story? No. And you see, no, there is no dog. And by the way, I spoil you that there is absolutely a dog in the story. So there is no dog is something that, is completely wrong. So what's the point? The point is that the most probable answer to this question is that we are talking about Pirandello, we are talking about a story, we are talking about what is the knowledge that is at GPT-4 disposal. And you discover that the answer will be a mix of all the stories from Pirandello's. And this is a mix of many other stories. It's not just specific to this one. So how can I be sure? How can I trust the GPT for that? And the answer is that you have to provide grounding, and you have two ways to do that. The first is providing a link, because if this link was available at the time the knowledge was, the model was trained, you are right. You can just give that. You are fine with that. Otherwise, you have to provide the entire story by yourself, which is something that we will see later on, okay? And if you provide the grounding, so a precise kind of information that you say, this is the truth, just elaborate the question, the answer, so that you give me a nice wording about that. And this, you see that there is this old dog performance, Celiac, La Carioda, wheelbarrow. So it basically takes the back legs going on as a wheelbarrow. And this is totally different story, right? So the reason is that the prompting is vital. Without the good prompting and providing grounding, you don't obtain what you expect, okay? So what are the reasons behind this hallucination? Because you basically have a machine that is able to generate, contextualize the natural language, okay, which makes perfectly sense, but the knowledge and the truth is a totally different thing. So the context depends on two factors. The knowledge stored at the model at the training time, which, by the way, may be wrong, because we know that on Wikipedia we can find a lot of mistakes, right? And the user prompt. So the tokens that will come out are generated according to the distribution probability, the Gauss distribution probability, okay? And the grounding is the key of success, because you basically say, okay, everything I give you is truth. So you can pick whatever you want inside this distribution of probability, but you pick from good stuff, okay? And the lack of grounding leads to hallucination. So you have to minimize the possibility that it picks up something which is wrong. And how can you do that? So basically, if you have all the information inside this bell, okay, this is the Gauss bell, you basically have distribution probability in where the top p parameter, which is something that you can specify along with the prompt when making a request to a GPT model, is the amount of information at the top of the bell that you want to retain. And then once you isolated the amount of information that you allow the model to pick up, you give the temperature, which you may also already know that, which is a random factor, which it can pick one of the tokens inside that, this area, randomly. Why the random factor? Because it gives us the possibility to, express like more like a human. If you make the exact same question 2 times, 3 times, 4 times, you obtain different answers. If you ask me to repeat this session 5 times, it will be never exactly the same. If you give a very low temperature, so you give temperature 0, you will obtain a robotic answer. Every time, always the same answer with the same tokens, like it was memorized, okay? Which is wrong from a human perspective. So remember, top p parameter is something that is which area identifies most of the truth that you have inside the knowledge. And how can you know that? It's difficult. I mean, if it's something that is very popular on the internet, this top p parameter can be as large as you can, because it doesn't matter. At the very end, you will end up having the possibility to pick anything inside all the distribution probability, because it's so widely known, it's so, persistent on the internet, which is an easy guess, okay? But if you have less knowledge, you want to diminish this top parameter so that you pick up only the points that really matters on them, because otherwise you risk of hallucination, okay? This is very important to remember. So there is still the possibility we get something that is wrong, okay? So how can we force, let's say, the possibility to obtain always good values from these long sentences generated by the models? So there are 3 answers, basically. The Retrieval Augmented Generation that we will see in a moment, using agents and tools and functions, which is something that I will briefly talk about it, because it will take a long time to expand the topic. And also the retraining, and also call it the fine-tuning the model. And I have to stress you about that. Retraining and fine-tuning the model is something that is usually not necessary, and that leads to worse result rather than the first 2. And the reason of that is that you are going to alter a bunch of parameters inside the neural network, and you risk to have something that worsen the results of many other topics. So it's unbelievably difficult to fine-tuning the model in order to obtain relevantly, significantly better results. So this is, something that I discourage absolutely to do. And is, it could be interesting if there is a topic that is completely unknown on the internet, and you have to train let's say, 20,000 documents that are very specific and very elaborate, and that they are very linked to each other. And when they are very related to each other, you have a huge amount, like a new discipline, okay? In that case, it may be the case to fine-tune the model, but it's extremely, extremely rare, so I discourage you to do that. So there is one important concept that we already talked about it, but we didn't just, pick it up explicitly. And this is the core on how these models works, which are the embeddings. The embeddings are multidimensional vectors, so are just plain numbers, vectors, the one that you put inside the braces, right? And representing the model state when processing the user input. So you basically give some input to the model at the center level. On the layer of the neural network, you have a number, a series of numbers. And these numbers represent the state of the neural network. And we already said that when you have the neural network, which is initialized with a certain numbers, you will obtain, the generation of text, which is basically conceptually inherent to what we have provided as input. This is the powerful, okay? So what if we bring these numbers and we take it away, and we store it separately? And I have to say this is a win-win situation, because we basically process the input without asking the output, but just stealing the inside numbers so that we can use it for later on for other purposes, okay? So that's the idea of the embeddings. And by the way, they are opaque numbers. So you cannot just see the numbers and say, hey, I found a 0.5 here. This is why, blah, blah, blah. No, you cannot do that, okay? So if you analyze all the numbers, even if you make a very strange thing, they don't provide any useful information. And also, you cannot even reuse that with a different model. They are very specific to a model family, let's say. So you have to be very, very careful when you generate these embeddings, because you may have to regenerate them in the future, as it happened recently with the new embeddings model in OpenAI. So the only way to measure and in some way to use these embeddings is measuring the distance between them. And this is hugely important, because we use it doing vector math. And you know that when you have an array of numbers, we have vectors. A vector, for example, is in 3D, the direction of an automobile in the highway, okay? That's the arrow that represents the vector. And how can you measure the vector? Oh, well, it's not the length of the vector. This is meaningless. In fact, when you compute the embeddings, you always reduce all the embeddings to length 1. And this is for mathematical purposes, because it simplifies the math behind the distance, okay? The only way that makes sense to process these vectors is to measure the angle, okay? And most probably you don't want to make the dot product, which is more like takes more steps to be calculated, but the cosine distance. So you basically calculate the angle. But while this is simple, let's say in 3D, you can imagine this, what's the angle between a pen and my finger, and you calculate the angle. And when you are in a very high dimensional space, like 3,000 dimensions, or or more. It's I mean, something that you cannot even imagine. So you just rely on math and nothing else. Why this distance important? Because these embeddings has a powerful information inside them. So when two of these vectors are very close to each other, and so the angle is very close, is close to zero, let's say, they share the same meaning and concept. This is kind of unbelievable. So if I talk about, repairing a car, and then I take another sentence talking about changing the carburetor of the car, you will discover that these vectors of the two sentences, even if they don't share the same keywords, they are close to each other. And this is mind-blowing, right? But you can try it and you will discover that is really astonishing. And so we can use that in order to find similar concept to each other. So basically the idea is that I take a text, I compute the embedding, and I store it away. And then one day when I get a question from the user, I recompute the embedding, and I compare the embedding with all the ones that I stored. I discover what is talking about this guy, because I associated the cars on the holidays, the kitchen, and the cuisine, and so on. And so every time you talk about a topic, you can identify the topic just and by comparing this. Just basically are doing categorization, right? Because you understand immediately which is the most probable category of a phrase, even if you don't have a single keywords that is matching, which is mind-blowing. And you can also, of course, using for semantic search, which is a search, but is basic on the concept that they are expressing in and not on the single words. And you can use it for recommendation, because if you are interested in a certain category of things, you may use that, or to find anomalies, because of course, when something is different from the other, is an anomaly. It's the only piece that doesn't fit in this category. And OpenAI and Azure, both of them, and there are many others, even offline, okay, expose REST endpoints to retrieve embeddings. So basically, instead of interrupting the computation of the GPT-4, they have separate models which just produce embeddings and nothing else. So you provide the text and you get back the embeddings. You provide the text, you get back the embeddings. And they are very cheap. I mean, the cost of the embeddings is super cheap. And you can reuse these embeddings for many uses, as we just mentioned. So I want to make an example which is totally different from the GPT model, and I have a nice example for you. So let's take Visual Studio, and this, I promise this is a very, very basic stuff. Let me do it this way. So basically, I have here an image. They are wallpapers, okay? And if I want to, this is not a data set that was prepared. 1977. Okay, this is the car that Niki Lauda in 1977 drove at the F1 Grand Prix. Okay, and I pre-indexed on a vector database that I have on Docker right here. Okay, it's Quadrant. Which just store the arrays, nothing else, okay? All these images, and you can see that these images are very different from each other, and it's not a science data set which can be special in some way. These are my wallpapers, okay? They are very different from each other. They have very different content. Okay, now I say I take the embedding for this, and I want you to give me all the images that are similar to that. And we will see what happens. So basically, I indexed all of those images. Okay, I will take the first embedding for this image, and I will search inside the database for all the distances, okay, with any other image. And you see that here we have a result which is okay. They are all are opened from the last to the first. This is Linux 003, and of course I have nothing to do. Why this is so different? Because the distance is 0.3, and you can see that the distance 1 is the source image, which is the one that Lauda, Ferrari, you see, the Dutch Grand Prix. That's it. So the distance from itself is 1, and the worst distance is Linux, of course, which doesn't fit at all. Then we grow the chandelier tree. The chandelier tree is, oh my God. Chandelier tree is this one. And you see, there is a car inside. It's still a very different car, but 0.4, it's a car. And then we have 42 Malaysian GP, and you can, you can understand that this is really a car, and a Formula One car. And then you have 22 and so on, which is a Ferrari. And then you have the Dodge Charger, and we are here, which is, the famous telefilm of the 80s. And then the Malaysian GP. And again, it's a Formula One, but you can see it's also difficult to understand this is a car. It's not that easy. So there is no pixel to pixel match. This is quite a difficult task. And then another picture from the Malaysian GP. And then 17, and you have this one. And then also these two cars, which are colliding, okay? And they're still Formula One. And finally, the original image, which of course is one. So the main idea here is to show you that you can apply this concept of similarity, not just to text, but to anything. You can apply to images. You can apply it to sound. You can apply to anything else. The problem is transforming the images to numbers, sound to numbers, and so on. And there are many strategies for that. So basically, in the operational phase, we indexed all the photos and we created the embedding. Then when I shot a new photo, I basically created the embedding on the fly for the new photo, and I will discover this is another data set, the flower data set, which is very well known, and that this is a flower, and therefore these also are flowers, and these also are flowers. And they are very different. They are different species, but the similarity is astonishing good. If we go back to embeddings and text, you have different models for that. So if you go to OpenAI and use the text embedding 3 small, which is 1536 length. By the way, this is because OpenAI used the Google GPUs, which is 6144, which is 1536 by 4. So if you multiply 1536 by 4, you discover that you have saturated the board, the physical hardware board, which have 6144 processors, but neural processors. They are not GPU. Okay, so this is very good, and we can have a conversation like 1 hour long about these embeddings, because they are called the matryoshka embeddings, which they can be reduced dynamically, and there is always long conversation possible on how you can treat these embeddings when you have them in your hands. But we don't have time for that. maybe another time. And every time you use the generative AI model internally, the model calculate the corresponding embeddings. And this is used to understand the context. So you can imagine, if you start from the image similarities, you basically have the same thing. So internally, the model say, oh, I have to identify, to extract the similar concept that I will use to extract one token at a time, the phrase that will be generated given that. So basically the flow now is I get the prompt as user input, I transform the user prompt in this state of the internal model. The state is given by these embeddings and few other things, okay? And given that state, you now start generating text. And you see that the embeddings that you can have in your hands is super important. You can do some reasoning about it, like semantic search. And okay, and we are now there. I mean, in this is a kind of mathematical proof that we have now that the structure and the goodness of the prompts is vital to obtain a good generation. So it doesn't mean that your user asking to copilot something should be, well educated about prompt engineering. This means that you must be well educated about that, because you can craft a good system prompt and then also a good user prompt where inside you will put the question from the user. And the user should not be a genius in prompt engineering, but you have to carefully build all the text that goes with it. There is a nice thing to go with embedding. So you can say, what kind of reasoning can I do in 3072 dimensions? It's difficult to understand. And in order to visually understand where a point is out of the cluster, and so is an anomaly, for example, you can say, okay, we can use PCA, the principal component analysis, well used in engineering since a lot of time. The TSNE is also very useful. Recently, UMAP emerged, but there is not a real winner. Okay, so you have to experiment. You have to be, if you want to be a data scientist, you probably want to give, a try on that. You may want to experiment with Python, which is, the language that I personally hate, but it's the mathematical tool, the best mathematical tool where you have the best libraries. And this doesn't mean that you cannot do that with .NET, and I love .NET. But simply when you are experiment, Python is the best field where you can experiment. Out of that, you can build, you have plenty of libraries in .NET to do, the final production stuff thing. And the goal is to minimize the information loss. So how can you minimize the information loss when you are reducing from a hyperdimensional 72 dimensions to 3, which is the maximum that I can see, without screwing up? These mathematical procedures works like projecting. The PCA works like projecting. So the projection is like a shadow, right? And so you have to find the right angle of the axis where you want to project without losing anything. Because if I have at noon and the sun is over me, your projection is a dot and it's very poor information. Instead, if you are, during the sunshine, your shadow will be long as this one, and your information is preserved because you can distinguish the human figure. So the goal of these mathematical procedures is to find the right way to extract the information. And when you maximize the variance of the data, you finally get the best projection. And the results are this one. So I indexed my own documents, and I can guarantee these are very indeed right. They have to be close. So I have identified this. The writings here are in Italian, sorry, but I have other examples so that you don't have to screw up with my language. And for example, the projection in 3D is, I took a very well-known data set and they processed by projecting in two categories. There are positive and negative answer. And you can see outliers here and here, okay? And this is something that I have had difficulties in understand by myself, reading those phrases. And so is this positive or negative? I don't know that. So I had difficulties in classifying that. And so this is a very good projection by PCA. This is UMAP. And oh my God, this is fantastic. When in data science, you can distinguish two clusters this way, you have to be super happy. You have to celebrate. And then also 4 categories. So these are news for I mean, news for the of the world, sports, business, scientific, technological stuff, and you see PCA, which is not that bad as it seems, because if you rotate the graph, you can find quite a few clusters. UMAP is better. You can see that is identifying that. And also LLE, which is another technique, was very good. And by the way, these are also something that can contain maybe sports and word, and also sports and business, or scientific word and sports. So they are, I mean, real news, and they are really difficult to classify. So what are other uses you can do with these generative AI models? So you have experiments by Microsoft.NET that having these smart components in filling automatically an address in the right field, which is, I mean, very good. Something that you can use without caring too much. I mean, zero effort and a great result. You have the smart text area, which basically suggests you something interesting, okay? And also the smart combo box, where you say, I want to choose something about food, and then you get everything, or all the words that are related to food, so you can filter out the content of the combo box. And these are things that will come more and more often. So it's something that you will see far beyond. So now that we have everything, sorry, I'm getting a bit late, but I asked the permission before. So we understand what is the semantic search. So semantic search, we already got to the point to understand what is that. And now we see how could you do that. So you basically have a private document that goes in an embedding model, and then you get back the embeddings, okay? You may chunk the documents. That's, I mean, something that needs a longer talk for that. But you basically store the embeddings inside the vector database, as I did it in my laptop with Docker using Quadrant, but there are many others, okay? And the operational phase is to give the user prompt in the embedding model, getting back the vector, okay, there will be only one, and to measure the distance. And these vector databases are able to do that, okay? And if you don't want to, I mean, waste time in doing all of that, there is Azure AI Search. Azure AI Search gives you the possibility to put your documents in a blob storage, for example, and then having indexer, splitting, chunking, and creating the embeddings. Of course, it will be much more expensive. That's something that, I mean, the balance is that if you put your knowledge there, that's okay. I don't want to enter too much in this Azure AI Search, because I already gave a session about that. And was also Swami was I mean, in the session there, in the Learn AI skills that you find in the internet from Microsoft. So there is a long explanation there, and you can search the video. And so we are now at the Retrieval Augmented Generation that will end up our conversation. So the RAG is something that mixed up the semantic search in order to provide the grounding that we talked at the beginning. So basically, you do what? You can provide either the link or the text, depending if they existed or not on the model's training. But we start from the fact that the documents were your own private documents. They never been on the internet, so you provide the text of the documents. And how can you do that? So you basically obtain these documents from the semantic search. So you basically make a search. Tell me what are the documents that talks about a semantic model, my own documents, and there is my own topic that I invented, semantic modeling. So the semantic modeling is something that I invented on the internet. There is almost nothing on that because I gave talks. And if I want to GPT to elaborate something explaining what are the main points, you basically have to go in that. And so I go to inquiries, I go semantic modeling, and I say, okay, tell me where I can find useful information on semantic driven modeling. And the trick is here, search private. This is the endpoint for Azure AI search that contains my document. And I am telling, hey, you know what? You should look at there. And you can see that the long answer that I get back contains these references that are the citations. And inside the answer, the models also tells me, look, where I put doc 1, this document is usual information about semantic modeling, resource false, and overcome the model versioning nightmare using semantic modeling. If I click, you see, this is a session that I gave at the time, okay? And so on. So you don't have to care too much about that. And when the documents are too long, you can request GPT to create a summary of that so that you can provide more documents inside the same prompt without spending too many tokens. And you delimit this block of documents with triple hash or whatever you want. If your documents or data is inside a database, you can ask GPT to generate a SQL query to retrieve the documents. And this is something more advanced that I usually talk when we talk about function tools and agents, because it requires, I mean, a longer thing. Can we do better? So we have seen semantic search, we have understood the large language model, when we have seen the retrieval augmented generation, that after you understand the semantic search is pretty straightforward. There's nothing different from what I did with the wheelbarrow story that I mentioned about my daughter. So the chain of thoughts is something that is an advanced technique in prompting that basically tells you have to explain the model that he has to reason step by step. So he has to provide not just write the solution of the problem, but to provide all the steps that are required to go to the solution. This is a technique that improves the quality of the answer because it forces the model not to invent the tokens generated before, but forces to go through the real context of the question. And these have given proven results, and I mean, it's something that you have to experiment with a prompt by yourself to understand, to fully understand. Then function tools. These provide the model the ability to request the invocation of deterministic. And I want to show briefly, I may have closed yeah, I probably closed the browser, but we should go there in a second. Come on. Of course, you get the, okay, that's it. Nice. So, for example, this is very, very straightforward. Weather, okay? So, I want to know the weather in, not in Genoa, where I live, Hyderabad, right now, okay? So, what's the weather? And how can the knowledge of the GPT knows Hyderabad where is? And it can't know, right? But I can use a function which is get current weather, and the model will decide to call this function or not depending on the context. And so since I ask it about the weather, the model understands and calls the function, but it doesn't call directly. It asks to you to invoke the API for weatherapi.com and to retrieve that. And it Misty with a temperature of 29 degrees Celsius, which is not too far away from what we have here, by the way. And so if I go to sniff the results here, let's see. No, not this one, not this one. 26. No, 26, the last one. Okay. What's the weather like in Hyderabad right now? I log everything in Markdown, and you see that I provided this function, okay? And the function out that I called on the request of the GPT model is this one. This is the call of an API that I made in the middle. Let's think about a callback, okay? And when I provide just this information to the model extract 29 and missed and build this phrase, okay? This is how the tools function work. And finally, the agents, which provide more sophisticated control over reasoning. This is something that works together with the chain of thoughts, which basically say, I first split the problem in several other small things to do, and then each one we call the model with a totally separate prompt, different prompt, and then the results will come back, and the orchestrator prompt will put all together, and the model will adjust that. But this is quite an advanced thing to do. So at the very end, how can we use the generative AI for? And we can do it for classification, we said, for semantic search, recommendation, of course, transformation. We can use summaries, translation, rich in description, different tones. And then content generation, you can create entire new documents or code, programming language code, we know that. And Copilot, user chatting, collaborating with a virtual agent so that we can ask, create a virtual waiver. I have an example about that, and so on. So this is all you need. So it's just a matter of providing a good prompt together with the other small things that we talked about. And so provide the most relevant categories, provide the outliers, or the user asked where to find them. So one of the things that you can do is, for example, put all the description of the menus and sections of your UI in the web application, and then you can ask the GPT to guide the user to the clicks so that he can find the right option in which section. If you think about Visual Studio with tons of options with a complex UI, you may guide the user to find the right option there. And also accessibility. This is super important. We have to care as developers. We have to care about people that has difficulties in accessibility. And you're an assistant guiding user through these menus and dialogues. you want me to save this PDF and so on. So you explain, you guide the user, you help the user on that. So I basically finished. I went a bit late. Sorry for that, but I asked Swami to give me the permission of doing that. And so we are done, and you can enjoy these images that I did on my own GPU locally. These are astonishing, and you can see the different results just repeating the prompt. This is for fun. Hi, we are done.
Thanks. Rafael, we have a query from Prasad.
Yeah, sure.
He's asking, is there a better fast way to do semantic search on text of documents? That was, I think, the first part of the query. And the second part of the query is asking, is Colbert slash FAISS a better vector search approach? These were the two queries by Prasad.
Sorry, but I will see, and just tell me if I understood correctly. But the main point is that yes, when you have like million vectors, the search can become slow, and this is something that there are techniques inside this vector database that are used in order to kind of cluster these vectors in order to diminish the amount of computation that you have to do in order to compute the cosine distance. Anyway, it mostly depends on your data. So if you have the possibility to create smaller clusters, of course, this is the way to go. If you can, I mean, save separately, given that you have a bunch of documents that you don't want to kind of pre-classify, you can do a pre-classification on your own, and you can say, I save the bigger categories in a separate table of the database vector, and say everything that talks about car maintenance, I take from the millions of vectors that I have, and I create a separate table. Everything that talks about, holidays, I put in this other. And if you can make this pre-filter and save it separately, this will give you a huge boost, of course. This is not always possible, by the way. I don't know if this can eventually answer or not the question, but
I
the
think
mathematical
definitely
technique.
this.
Yeah, please.
Go ahead, Rafael.
I mean, there are mathematical techniques to improve that, but they are up to the vector database, and everyone is doing these optimizations because they are well-known mathematical procedures. You don't have to waste time by implementing by yourself. The vector database is going to offer that to you. So you are certainly not going into like kind of Redis and then using the cosine distance by yourself. That's not the way to do. You have to use a vector database, whether it's Azure AI or Quadrant or Vespa or whichever you want.
Okay.
Do you have
Okay.
other questions?
Oh, the same. Only query was from Prasad. I think both were related. One, he was asking the better way to search, and another call COLB. Oh, okay, makes sense. Thanks so much. He answered. He put it in the chart. So looks like you have answered his query, and
Okay.
that's great. We had only query from Prasad. Thanks, Prasad.
Okay.
And thanks,
Thank you.
Rafael, for the wonderful session. Hope everybody would have learned something new. And thanks so much.
Thank you for having me, and see you next time.
Bye, folks.
Bye-bye.